Basically, use substitution. What it is the backwards chain rule. So let's just remind ourselves real quick about what the chain rule is. So if I have sine of 4x and I want to find the derivative, what would the derivative of sine of 4x equal? 4 cosine 4x, because you have to multiply by the derivative of the inside, right? Right now we're just talking about derivatives for a second, so I can remind you what the chain rule is. So we're talking about the chain rule just so that you can be thinking about it. Okay, what if I have x squared minus 3 to the 10th, and I want to find the derivative? What would I do? Ten times x squared to minus 3 to the 9th, multiply by the 2x, right? Because the derivative of the inside, that's the chain. So in this problem, the 4 was the chain, and on that problem, the 2x was the chain. Okay, so what we're doing is we're starting with problems like these that have something that you would use the chain rule for if you were doing the derivative. You can't use the chain rule because we're doing the antiderivative. Okay, so we're going to be doing a process, and it's called use substitution. It's not a rule. Okay, chain rule is a rule. When you see this, you multiply by the derivative of the inside. Okay, use substitution is not a rule. It's a process, and it's a way that we can do the chain rule backwards without actually doing it. Okay, it's going to seem kind of weird at first, but I think you're going to get the hang of it. So let's look at a couple problems. So let's say we want to do the integral of x squared plus 1 to the 5th times 2x. Now the first couple we're going to do, you're going to probably get to the point that you're going to think, I don't even need to do use substitution, and I understand that. Okay? However, once I show you what use substitution does whenever it doesn't look like the first couple, you're going to see where it might be helpful to you. Alright? So, I want to find the antiderivative of this. If you were just sort of guessing, what would you think the antiderivative would look like, or at least part of it, what it would look like? So I think that the antiderivative is going to have a 6 power in it, because that's 1 more than the 5. Okay, that's true. So our power rule only applies, though, if what's in parentheses is an x. Okay, if it's x to the 6th, I can do that. Or x to the 5th, or x to the 1/2. But because what's inside of there is something different and has to do with that chain rule, I've got to do it differently. Okay, so here's what you do. You're going to let u be the part of the problem where you would use the chain rule if you were finding the derivative. Okay? It's going to be x squared plus 1. So even though we're finding antiderivatives, we're sort of thinking, okay, if I did the derivative, what would be the part I would have to go back and multiply by the derivative of? Okay? Then you find the derivative of u. Okay? Sort of like you are finding the chain rule. So what's the derivative of u? 2x. Okay. After you decide what u is going to be, and after you find the derivative, you're going to go back and take those things and substitute them into the problem. Okay? So I'm going to rewrite the problem. So x squared plus 1 is u. So I'm going to have u to the 5th. du is 2x and then this extra dx that we just kind of put there. Okay? That's what's left over, right? So I've rewritten the problem now as u to the 5th du. When you rewrite the problem, your problems with the chain rule go away, because I know how to find the antiderivative of this. What's the antiderivative of the u to the 5th? 1/6 u to the 6th. So then I go back and I substitute what u was back in, and this is the answer. Like I said, I figure that some of you are going to be able to figure this out without doing this whole process. And if you're able to, it's fine. Whenever the 2x changes to something else, that's when this is really, really important. And I will show you that in a minute. The 2x sort of just goes away because it's part of du. Okay? And whenever it's part of du, it just sort of goes away. It's sort of like we're eliminating what we would have multiplied the derivative by. We're eliminating it from our thought processes, so we really just have something to a power. Okay? Now, the 2x will change. It won't always be just what the derivative is. It might be something else multiplied by it, and I'll show you that when we get there. But that's the process, but you use that process every time. Okay, so I told you that you always let u be whatever the thing is inside that if you were finding the derivative that you would do the chain rule on. So what do you think u is going to be? 5x. Okay, so du is going to be 5. Okay, so 5 and then your little dx if you want to put it there. Okay. So this is u. This part right here and this part right here is like du. So we have the integral of cosine of u du. Cosine is still there. On the last problem, you know how the power was still there, like the fifth? Well, on this problem, cosine is still there. Okay. So now I want to find the antiderivative. What's the antiderivative of cosine of u? Sine of u, right? And then plug back in your u. So this is one that I think is a little bit more difficult. You still might be able to do it. I don't know. Some of you probably can do it without figuring it out. But I think that the u substitution is important. Okay. So first of all, think about the derivative. I understand that if you did the derivative, you'd have to use the product rule and all that kind of stuff. But what would be the part that you would have to go back and find the derivative of in the chain part? This part inside, right? Okay, so here's what I'm going to do. I'm going to let u be x cubed plus 1. And du is going to be 3x squared dx. Okay, so here's what makes this different than the last ones. There's a 3 on my dx. There's not a 3 in the problem. See that? Well, if I want to make it like the last ones, I need the 3 to be there. So I want to put a 3 there. But if I put a 3 there, I don't want to change the problem. I don't want to change the problem. Listen. If I put a 3 there, I need to also multiply by 1/3 so that I haven't changed the problem. Okay? Because 1/3 times 3 is 1. Right? So what I'm going to do is I'm going to put a 1/3 on the outside, because you can always do that with things that are multiplied. Okay. So here's what we're going to do. This part right here is the u. This is the du. The 1/3 on the outside is just going to stay there, because it's not really part of the integral. I just took it on the outside, which you can always do when you're multiplying. So you've got 1/3 integral u to the 1/2 du. So I changed all the variables, and I took a 1/3 on the outside to make this 3x squared work the way I want it to. Okay? So now I'll just find the antiderivative. The antiderivative of u to the 1/2 is 2/3 u to the 3/2, right? And then the 1/3 on the outside just multiplies by it. So I get 2/9 and then plug what u is in there. Okay, so we want to find the antiderivative here. Do we know what the derivative of tangent is? Secant squared x, or secant x squared, okay. The tangent of x plus 3, think of it as raised to the first power if you want to, but maybe you could think of it as to the 10th power or the 20th power, whatever, to think about what would be the chain. So if you found the derivative, what part would you have to go back and multiply by the derivative of? Okay, so that's what I'm going to let you be. You guys just told me that the derivative of tangent was secant squared of x so there's an extra 2 there, right? Is that what you're asking me? This 2 right here is kind of extra. So, if the 2 is already there, like if you don't put anything in there, the 2's already there, you can take it out and leave it as a 2. On this problem right here, you put in the 3 and you took out a 1/3 so as not to change the problem. Here, the 2 is already there. Okay? So what I'm going to do is I'm going to just put it out here, but I'm not going to change it. So I'm going to make it 2 integral of what? Secant squared is the du. This is du. U. 2 times the integral of u. So you can always take out constants, numbers that are multiplied. If you put them in, you got to multiply by its reciprocal. But if it's already there, you just bring it out. Okay? So what is the integral of u? 1/2 u squared times your 2 that's on the outside. What's the integral or antiderivative of u? That's like u to the first. So you add 1 and divide by it. It could be u squared over 2 if you want it to be.
Where did 1/2 come from?
Okay, so we end up with 2 times 1/2 is 1, and then u is tangent x plus 3 squared. And again, we could check it if you wanted to. The derivative there would be 2 tangent x plus 3 to the first times the derivative of what was inside, which is that secant squared of x. So yeah, that makes sense. That's correct. These are usually pretty easy to check. Other than the multiplying, it's usually pretty easy to check because of the chain rule. Okay, let's do another one.
It's just confusing because the du's just go away, like there's no point in it being there.
I'm with you. Oh.
Like there's absolutely no point in it being there.
Very similar to the other problems. What do you think you would be? Okay. So if u is 2x minus 5, du is 2. There's not a 2 there. There's 3. But there's not a 2. There's got to be a 2. So what can I do? Put a 2 in there. Take a 1/2 on the outside. Okay, what about that 3 that's in there? You can multiply it. I wouldn't multiply it by the 2 because that 2 is part now of du. But I could take it like on the outside like I did on the last problem. I could multiply it by the 1/2 on the outside. I think that's easier. Any numbers that's not really part of your u and du, I would take it on the outside. And you don't have to change it when you do that. Okay? So it becomes 3/2 on the outside. And then that 3, or the 2 and the dx, that's all du. So 1 over u squared. And then I just put the du beside of it instead of on top of it. Okay, so we're going to think of this as u to the negative 2, right? So we add 1, negative 1, and divide by it so that negative's out there with the 3 halves. And then u to the negative 1, and then substitute it in. So here's your try problems.